Hello, Math 2. This is Mrs. Bricky, and this video is for Unit 6, Lesson 2. We're going to be talking about inscribed angles. An inscribed angle is an angle whose vertex is on a circle. So the vertex, remember, this is the vertex. So in this case, the vertex is right on the edge of the circle, and the sides of that angle are chords of the circle. I mean, in this example, it kind of shows them as rays, but you can see the two chords there. The arc that lies in the interior of that inscribed angle and has its end points on the angle, that's called the intercepted arc. So we've got an inscribed angle that I've kind of colored green, and the intercepted arc is in blue. So in class, we did a little activity to discover the relationship between inscribed angles and arcs, but you're at home, so I'm going to skip that. All right, so we'll just go straight to the punchline. If you have an angle that is inscribed in a circle, so we've got this angle right here, then its measure, so the measure of this angle is going to be half of the intercepted arc. So, for example, if that intercepted arc was 120 degrees, then we would know for sure that this angle is half of that, 60 degrees. So find each requested measure. So in this example, we have an arc that is 162. So the angle is going to be half of that. The angle right here is going to be 1/2 of 162, which is 81. So this angle will be 81 degrees. In this next example, we have an angle right here, 23-degree angle. So to get the arc, we would multiply by 2. So this would be 46 degrees. And we got that by multiplying 23 times 2. So if you know the arc, you divide by 2 to get the inscribed angle. If you know the inscribed angle, you multiply by 2 to get the arc. All right, so we've got some little bit more complicated diagrams now. We want to find the measure of all of the arcs and angles in these diagrams. So let's start with this angle right here. We've got a 45-degree angle. So that means if we double it, we will get the arc. So this must be a 90-degree arc. We also have over here a 40-degree arc, which means that the angle must be half of that, so 20 degrees. So again, if you have the inscribed angle, double it to get the arc. If you have the intercepted arc, you divide by 2 to get the inscribed angle. So we have 2 more arcs in this circle that we need to find. So look at this, diameter is going to help us. So if this is a 90-degree arc from A to D, then this would also be a 90-degree arc from A to B because we have a semicircle there, so it should add up to 180 degrees. And on the other side, we've got a 40-degree arc, and these two have to add up to 180 degrees. So 180 minus 40 gives us 140 degrees. So we finished that diagram. We have all of the angles and arcs. We have the angles and arcs all measured, all written out. All right, so let's look at this next diagram. It's a little weird because it has a triangle inside of the circle. So it sometimes makes it a little harder to see the intercepted arcs, but sometimes what helps is I'm going to do a little bit of highlighting. This angle, 50 degrees, it's from here, and its other side goes to here. So its intercepted arc is this one from J to K. So if that's a 50-degree angle there near H, this arc would be 100 degrees. I need to times it by 2. On the other side of the circle, let's see if we can get rid of that yellow. On the other side of the circle, we have a 70-degree angle. And the arc that it intercepts, so if we follow the sides of that angle, it's the arc from J to H. It's this arc. So if that's a 70-degree angle, then the arc would be 140 degrees. We'll times it by 2. Now there's a couple ways of thinking about this last arc and angle. So I'm going to think about it from the perspective of arcs, and then I'll talk about it from angles. We have a circle that's 360 degrees. We know that we have an arc of 140 degrees and an arc of 100 degrees. So if we subtract, I shouldn't need a calculator to do this. Okay, if we subtract 360 minus 140 minus 100, we get 120 degrees. So that's this arc down at the bottom. And that means that the angle J, the inscribed angle with the vertex at J, intercepts a 120 degree arc. So if we divide 120 by 2, we find out that this is a 60 degree angle. Now, we could have thought about that a different way. So I'm going to just show you the different way as well, because it pays to sort of know more than one approach to a problem. It might be that you remember that the angles in a triangle add up to 180 degrees. So if we take 180 and subtract 50 and subtract 70, we know that this angle is a 60-degree angle. So we could have started by finding the 60-degree angle, and then to get the arc, we could have doubled to get the 120. So there's several approaches to most of these problems. Okay, this says, in many cases, we cannot find what we are looking for directly. So in this example, it asks us for the measure of arc JK. Well, that 26 degrees does not help us find JK directly. That 26-degree arc, though, tells us about our circle. So that 26-degree angle, I'm sorry, I think I said arc. That 26-degree angle tells us how big this arc is. If that's a 26-degree inscribed angle, I double it to get the intercepted arc. So this arc is 52. Now that I know the arc from J to L is 52, now I can use my diameter to get the arc I'm looking for. 180 minus 52 gives me 128 degrees. And that's my answer, 128 degrees. So you may have to find a different arc first on your path to getting the arc that was requested. On this example, it asks us for the angle from P to Q to M. So this angle right here. Well, we don't know that arc directly at first, but we know we have a 113-degree arc from Q to P and a 118-degree arc from Q to M. So if we do a little bit of subtraction, we know a whole circle is 360, and we can subtract the two known arcs, minus 113, and we get 129. So this is 129 degrees. Well, the angle that we're after is going to be half. This inscribed angle is going to be half of its intercepted arc. So if we divide by 2, we find out that this is a 64.5 degree angle. And don't stress out if you end up having a decimal come up. Sometimes they do. It's not a big deal. All right, the next few theorems are just direct consequences of our theorem about inscribed angle measures. So this first theorem says if two inscribed angles of a circle intercept the same arc, then those two angles have to be congruent to each other. So looking at that diagram, we have angle B right here, and it intercepts the arc from A to D. So whatever that is, I'm just going to give it a number to help you see. Maybe that's a 60-degree arc. That would mean this is a 30-degree angle. But we also have angle C over here, and it intercepts the same arc. See how that intercepts the same arc? So that one has to also be 30 degrees. So you can see that the angle at B and the angle at C are each 30 degrees. And I really didn't even have to know any numbers to know that those two angles are equal to each other. Because they both intercept arc AD, they both are half the measure of arc AD. There's a couple of other congruent angles in this diagram. Can you see them? We also have this arc over here that is intercepted by this angle and this angle. So the angle at A and the angle at D would be the same measure. This theorem, let's see. This theorem kind of is cool. It's a cool theorem. And I have this little diagram to kind of just show you that no matter where I put that inscribed angle, that 82 degrees doesn't change. Now, if the angle changes, whoops, let's see. So let's make it smaller. So, okay, here we go. So if I move point C, you can see that no matter where I put it, that's going to be a 37-degree angle. And the yep. Anyway, so that's kind of a cool way of thinking about it. So we know we have a 74-degree arc here. So the inscribed angle will be half of that. No matter where we put it, no matter where that vertex is, it's going to be half, which is 37 degrees. Okay, so this diagram asks us to find the value of x. So we have these two inscribed angles right here. One of them is 2x plus 14. The other one is 5x minus 13. They both intercept the same arc, which is right here. So that means they must have the same measure. They must be congruent to each other. So 2x plus 14 is equal to 5x minus 13. So if we add 13 and maybe subtract 2x, we get that 27 is equal to 3x. So that means x is equal to 9. And we were able to find x because we recognized that those two angles were congruent. Okay, if all of the vertices of a polygon lie on a circle, the polygon is inscribed in the circle, and we call that circle a circumscribed circle. Not every triangle or every quadrilateral can be inscribed in a circle. I mean, it's certainly possible. I mean, they all can't. Not every triangle can be, but anyway, you have to have all three or four vertices on the edge. So, for example, this one would not be inscribed because only 2 of them are on the circle's edge. So our next theorem is going to be about inscribed triangles, and then we'll talk about another theorem that has to do with inscribed quadrilaterals. So if we have a circle, this circle is centered at point V, and RU is a diameter. We want to think about what is the measure of angle RSU. So this is what we want to think about right here. Well, let's think about the arc that it intercepts. That angle connects to the circle at point R and point U. So we need to use this arc to find the measure of that angle. Well, that arc is a semicircle, so it's 180 degrees, which means that this is a 90-degree angle. We have a right angle right there. So here's our theorem. If a triangle is inscribed in a circle, and it's a right triangle, then we know that the hypotenuse of that right triangle is a diameter of the circle. We know that if we have a right angle, we know that that hypotenuse hits the center of the circle or goes through. If the side of a triangle inscribed in a circle is a diameter, so this is sort of the reverse, if we have a triangle and we know that that's a diameter, then we know it's a right angle. So this first question, or first example about this theorem, says find the measure of arc CB. So ultimately, our goal is to figure out this arc's measure. Okay, well, we have this diameter right here. So we know that this angle has to be a 90-degree angle. And that means that the other two angles in the triangle have to also add up to 90 degrees. So we know that 4x plus 5 plus 5x plus 13 is equal to 90 degrees. So combining like terms, we have 9x plus 18 is equal to 90. So we'll just combine those two together and combine those two together. If we subtract 18, we get 72. And so we solve for x, and x is equal to 8. Well, this asked us to find the measure of arc BC. So to figure out the measure of arc BC, or CB, we need to know how big this angle is. So we're going to sub in the 8. 4 times 8 plus 5 is 37 degrees. So now that we know that angle, now this is an inscribed angle with the vertex on the side of the triangle, or sorry, on the side of the circle. So we know this arc is double that. So that would be 74 degrees would be our answer. Okay, we're going to do a little angle chasing for a second to lead us to our next theorem. So this says find each requested arc and angle. So we're going to just work on our diagram for a minute, and then we'll fill in our list. All right, so I can see first of all, notice that we don't have any diameters, so we can't rely on a diameter for this diagram. We do have a 50-degree angle, and it intercepts the arc from C to A. So we have this arc. I'm going to just dot it out here just because B is kind of in the way a little bit. And we know this arc from C all the way over to A is a 100-degree arc. And we know that this part of it from C to B is 48. So we can do 100 minus 48 to figure out that the arc from B to A is 52. And having that point B in the middle of that arc kind of makes it hard to see that, but hopefully you can see it now that we have it sort of drawn out. So we know from C all the way to A is 100, and so we know that from B to A has to be 52. All right, well, we have all of the arcs in the circle now except for one. We don't have that top arc. So we can use 360 degrees and we can subtract the arcs that we know to get that remaining arc at the top of the circle. And I got 104 degrees when I subtracted that. So we have all of the arcs now. Now we just need to think about the angles. So I'm going to erase this just to clean it up a little bit. So to figure out, let's start with angle A. We'll just kind of go alphabetically. To figure out angle A, we need to notice that it intercepts the arc from B all the way over to D. So that arc has two pieces in this diagram. It has a 104 degree piece and a 48 degree piece. So if we add together 104 plus 48, that's going to give us that whole arc, which is 152. We need to divide by 2 to get the central angle. So that central angle is 76 degrees. Now let's find our next angle. That's going to be angle B. So angle B, if you can see and imagine the arc that it intercepts, it's from A all the way over to C. So it's this huge major arc. We need to add together the 156 and the 104. That gives us a total of 260. And since we're finding an inscribed angle, we need to divide by 2 to get 130. Okay, we're almost done. We just have angle C left. So if we're focusing on angle C, it intercepts the arc from D all the way over to B. So it intercepts these two arcs added together. So 156 plus 52 is 208. We're finding the intercepted angle, so we need to divide by 2, and that gives us 104 degrees. Okay, so let's fill in our list over here. The measure of arc AB was 52. The measure of arc CD was 104. The measure of angle B is 130. And the measure of angle A is 76. And the measure of angle C is 104. So we just found all those angles and arcs. So we've got a little question here at the bottom. It says, do you notice anything about the angles, the opposite angles of the quadrilateral? Well, I have angle B that is opposite from angle D, and I have angle A that is the opposite side from angle C. So do you notice anything about those pairs? Hopefully that you notice that the opposite angles add to 180 degrees. And that is always true for a quadrilateral that is inscribed in a circle. So if a quadrilateral can be inscribed in a circle, then its opposite angles are supplementary. And if the opposite angles of a quadrilateral are supplementary, then the quadrilateral can be inscribed. So when I look at this diagram, angle E plus angle G has to add up to 180, and angle F and angle D have to add up to 180. So the ones that are across from each other are supplementary, or they add up to 180. All right, so let's do this example. I have a quadrilateral. It has 2 inscribed angles that are given to me and 1 arc. So let's start with those opposite angles now that we know they add up to 180. So if 110 plus this angle have to equal 180, we can calculate that size of that angle. That's 70 degrees. And this one will have to be 180 minus 78, which is 102 degrees. So we've calculated all of the angles in the quadrilateral. Now we're going to use those angles to figure out the arcs. And this, I think, is a little bit trickier. Let's use the 110 degree angle first. That 110 degree angle intercepts the arc all the way over here. So we can get the measure of that full highlighted arc by doubling. 110 times 2 is 220. But we already know this part of it is 125. So if we subtract 125, we get 95. So this arc is 95. Together, they add up to 220, which is twice the inscribed angle of 110. Okay, so let's try another one. Let's use the 78 degree angle. Why not? So you can see the 78 degree angle inscribes an arc, or intercepts an arc, right here. So 78 times 2 gives me 156. But we can see we already have 95 degrees of that arc accounted for. So we'll subtract 95 to get 61. So this arc over here is 61 degrees. All right, we're almost done. We just have one little piece of an arc left. It's that little piece at the top. And we could use an inscribed angle to help us get that last arc, but we also can just realize that it's the only piece of the circle that's left. So we could just do a little bit of subtraction to help us get the answer. And when we do that, we find out that this is a 79 degree arc. So we're done. We've labeled all the arcs and angles. All right, that's it for inscribed angles. When you're working on a circle diagram, try to fill it all in before you answer if you have a specific list of questions. If you're getting stuck on anything, let me or your math teacher know. Thanks a lot.